Okay, so here's section 12.6, which is properties of logs. There's 3 log properties. The first one is log base b of x plus log base b of y equals log base b of x times y. So the adding of 2 logs becomes multiplication for 1 log. Logs, have a base. See how these all have base b? Property 2 is almost the same. Log base b of x minus log base b of y. So subtraction instead of adding becomes dividing. So, and then the third property is log base b of x to the power p. The power can come down to the front, like that. So there's the 3 properties of logs. The way I remember them, one of the ways I remember them, is, so notice they all have log b. Log b, 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 log b. So the b is not going anywhere. It's not about the b. It's about the x and the y and the power. And so what they do. Well, basically, here's the deal. You know how the saying, when many hands make the job lighter? I don't know if you've seen that saying. So basically, a job's easier with 2 people. That's a saying. Many hands make the job lighter. A job is easier to get done when you got 2 people instead of 1. Well, that's kind of what's going on. That's a way to help you remember these operations. If you think about the operations, multiplying and dividing are harder operations than just adding and subtracting, right? Multiplying and dividing are higher up, harder. These are the harder operations. And these are easier, right? It's easier to add, subtract. Multiply, divide, it's harder. Well, basically, you have the harder job for 1 log. So if you just have 1 log, it's a harder job. If you have 2 logs, that's the easier job. For 2 logs, it's an easy operation. It's just adding, subtracting. So a job that's easier for 2 logs is harder for only 1 log, right? 2 logs become 1 log for the harder operation. It's a harder job for 1 person, easier for 2. It's just adding for 2. For 1 log, it takes multiplication. For 2 logs, it's just subtraction. It's just easy. 1 log, it's harder. It's dividing. And then the third property is just the power coming to the front to multiply. Okay, well, so what? So let's use those properties now. Okay, so here's question 1. It says log base 8 of 9 plus log base 8 of 2. So see how they're both the same base? The log base 8, that's not changing. We don't mess with the base. It's like it's just glued to the G. We don't do anything with the base. But what do we do with the 9 and the 2? Well, it's adding. Easy job for 2 logs. Adding becomes times 9 times 2. Multiplication, right? Harder operation for 1 log. 1 log, it's multiplication. 2 logs added. So can we simplify that? That's log base 8 of 18. 9 times 2 is 18. There we go. Let's try the next one. Log base 6 of x plus log base 6 of x plus 8. So they're both log base 6. Adding, easy job for 2 logs, becomes times a harder job, multiplication, for 1 log. And that's the answer. That's all we got to do. These are pretty quick. Number 3. Coming on down here, we've got log base 6, log base 6. See how the bases are always the same? That doesn't change. That 6 is just glued to the G. Subtraction, an easy job for 2 people, for 2 logs, becomes, well, what does subtraction become? Remember, subtraction makes things smaller, right? When you subtract, they get smaller. So that goes with division, doesn't it? 20 over 4. And then you can simplify that. That's log base 6 of 5, right? 20 divided by 4 is 5. That's our answer. So basically, adding becomes multiplying for 1 log. Adding for 2 logs times multiplication for 1 log. If you want, you could multiply these. It doesn't matter. Back on this one right here, you could have said x squared plus 8x. It's good either way. You know, you don't have to do that. If you leave it this way, it's okay, or this way, it's okay. Either one's okay. Because this means times, right? All right, so yeah, and then subtracting, so adding makes things bigger, so that goes with multiplying. Adding makes things bigger, that goes with multiplying. But subtraction makes things smaller. Easy job for 2 logs becomes dividing. That makes things smaller for 1 log. There we go. Let's try the next one. Here we have 2 logs subtracted. They're both log base 3. The bases are always the same. Subtraction becomes division, a harder job for 1 log. Okay, so number 5. Now this one, we're just going to take that power, it's just going to come down to the front. So it's going to be 5 times log base 3 of x, and we're done. That's it. These are pretty quick. Okay, now number 6 is a little tricky. It's tricky because you have to know what a root does. So remember that if you have anything like to the a over b power, that b swings into the hook like that. So that's the connection between fractional powers and roots. So this is fractional power, and this is a root or a radical, it's called. So yeah, so the denominator swings into the hook, and the a just stays put. So x to the a, that hasn't moved. But the denominator swings into the hook. Okay, who cares? Well, that means this one, here, let's bring it over here, log base 9 of the 5th root of y, we've got to realize that's y to the first. They're not showing a power, so it's got to be y to the first. That's equal to log base 9, again, the 9's not going anywhere, that's just glued to the g, of y to the 1/5. Do you see how I did that? Because that 5 could swing around and go in the hook like it is. You can go either way. You can go from the hook back to the denominator, or from the denominator back to the hook. Either way. These two are 2 ways of saying the same thing. You can go from hook back to denominator, or from denominator back to hook. Either way. So I took it here from hook back to denominator, like this. Let me put it back the way it was here. Y to the 1/5. Now why? Why am I doing that? Because then I can use that third property right here, which says powers can come down to the front. So once you've got it up there as a power, you can take it and bring it down to the front. So it's 1/5 log base 9 of y. There it is. All right. Let's try number 7 down here. So first thing is I'm going to grab that 2 and put it up in the power. Get the idea? So property 3 says powers can come down to the front, but powers can also go back. Numbers in the front can go back to the power. It's either direction. These properties, we can run them either way. It's just saying this is the same as this. Use whichever one you want. You can put the power on the thing, or you can put the power in the front, just whatever's easier at the moment. Property 3. So I'm going to take this and put it up here. So what am I going to get? Log base 9 of 7 plus log base 9 of 4 squared. And then, once I've done that, I can combine them into 1 log, right? Because of the fact that adding for 2 logs, log base 9, the 9 is just glued to the g, becomes multiplication for 1 log. Harder job for 1 log, multiplication. And then multiply that out, that's log base 9 of 7 times 16, what is that? 70 and 42, 112. So it's log base 9 of 112. There we go. Okay, so now let's look back. I should have said that this last question, look at the instructions. They said make it a single log. Make it a single log. So that's why I made it into 1 log in the end. Make it a single log. So now it's the same thing here. Make it a single log. So they want me to take these 3 logs and crunch them into 1 log. How am I going to do it? Well, it's going to be 1 log base 6. See, they all have the same base. They always will. And then you're going to take 3. The adding becomes times 14. the subtraction becomes divide 7. Just make all three into one big log like that. Adding becomes multiply. 3 times, you can do parentheses if you want, 3 times 14. And then the subtraction becomes divide. Now, can we simplify that? That's log base 6. 7 will go into 14 2 times. 2 times 3 is 6. So that equals log base 6 of 6. Now, when they match, see how these guys match, 6 and 6? That just always equals 1. You can try it on your calculator. Like we learned from the last section, and if you did that on your calculator, on the last section we learned how to do these logs, that the top one goes on the top and the bottom one goes on the bottom. So this one goes on the top, this one goes on the bottom, and that's clearly just 1, isn't it? So the answer to this whole thing is just 1. That was weird. Okay, let's try the next one, number 9. Again, make it one log, a single log. So here we go. It's going to be 1 log base 4, right? They're all log base 4. They got to have the same base or we can't do any of this. X minus, so x divided by x minus 5 plus, that means times, x squared minus 2. Right? Because plus means times, minus means divide. Now, can I clean that up? You can, this is over 1, so it goes to the top, huh? So x squared minus 2, if I'm not writing very neatly there. This is over 1, so it's x squared minus 2 over x minus 5. There we go. We made it, what did we do? We made it a single log. 1 log. Subtracting became divide, adding became multiply, and we put it all together into 1 log. So there it is. It takes a while just to type that in. Okay, so number 10 here. Same kind of thing, make it a single log. Crunch these together. Well, those numbers in the front, I have to take them up to the power zone. 2/3 to the power. 5 to the power. So it'll become log base 8 of x to the 4th minus log base 8 of x to the 2/3 power plus log base 8 of x to the 5th. That good so far? So numbers in the front go back to the power. That's property 3. Now combine them all into 1 log. They're all log base 8. See how all the bases are the same? So it's x to the 4th over x to the 2/3, right? Because that subtraction becomes divide, plus times x to the 5th. Okay, now we have some trickery to do. Let's see. So this is over 1, so it goes to the top. So we have log base 8 of x to the 4th times x to the 5th over x to the 2/3. What do we do with that? Well, let me go to a fresh screen here. We have, what number is this? This is number 10. 10, so log base 8 of x to the 4th times x to the 5th over x to the 2/3. Yeah, powers, do you remember the rules of powers? When powers are side by side like that, they add. So that's going to equal x to the 9th, 5 plus 4 add, over x to the 2/3. And then when they're vertical like this, like what x to the 7th over x squared, that'd be x to the 5th, huh? They subtract. Remember that rule? So what I need to do is subtract. I've got to take 9 minus 2/3. I've got to subtract the powers. Now how do you take 9 minus 2/3? You put 9 over 1, right? Common denominator, top and bottom by 3. So that's 27/3 minus 2/3, which equals 25/3, doesn't it? So 9 minus 2/3 is log base 8 of x. Still got x in there. The base is still x. It's just you subtract these powers. 25/3. There it is. Okay, number 11. write the expression as a sum or difference of logs. So this time they want me to make it into lots of logs. So I'm going to break it up, right? I'm starting with 1. So it's the opposite direction. Some of these other problems, back here, I started with lots of logs, and I made it into one log, made it a single log when we were all done. Right? There was the single log. Now on number 11, I'm starting with one log. I want to make it lots of logs. How do you do it? Well, it's going to be log base 6 of 3 divided by 8z. What's that? That's going to be minus log base 6. They're all going to be log base 6, right? The base never changes. Of 8 minus log base 6 of z. Does that make sense? Both the 8 and the z are in the denominator. They're both divided. I know you might look at it and go, well, it's 8 times z. Yeah, kind of. I mean, it is, but they're both really in the denominator. So they're really divided. And so both those logs are subtract. Remember, dividing becomes subtraction. Easier job for lots of logs. It's harder for one log, multiplying, dividing, becomes subtracting here. Well, there's no multiplying, there's just dividing, right? This is 3 divided by 8 and divided by z. So I subtract the 8 and subtract the z. They're all log base 6. You never change the base. It just becomes easier for 3 logs. Let's try this one. Now, what does that square root do? Okay, let's go to a fresh screen, get more room. So that square root, we got to talk about that. Here, let me get a fresh screen. So when you have the square root on something, remember what we've learned. Let me remind you of fractional powers and what they do. If you have x to the a over b power, what is that the same as? The denominator can swing in the hook, right? It's the bth root of x to the a. Well then, okay. What would be the square root of x? Well, square root of x, there's really a 1 power there, huh? And what's really in the hook? An invisible what? 2, huh? That's why we call it a square root. Square means 2. Okay, so that's the same as if you swung that 2 back to the denom, that's the same as x to the half. So you get it? What that's saying is the root on anything, if there's nothing showing in the hook or in the power, that's the same as that thing to the half power. So if I have blah, blah, blah with a root on it, that's the same as blah, blah, blah to the half power, right? The root of anything is the same as that thing to the half power. Because a half, the 2 could swing around, the 2 could swing around. It would be the 2 root of the blah, blah, blah to the 1, which is just the root of the blah, blah, blah. Because the 2 is understood in the root, the 1 power is understood, it's the same thing. So what's the moral of the story? Anytime they give you root of blah, 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 you can make it blah, blah, blah to the half power. All right. There's our blah, blah, blah. It's root of 2x. So that's log base b of the whole 2x to the what power? Half, right? Remember, a root over 2x is the same as the whole 2x to the half power. And then what can we do with powers? With logs, property 3 says they come on down to the front. So that's a half log base b of 2x. You do need those parentheses around the 2x like that. That's our answer. That's as far as we go. What do we do? Oh, no, I'm sorry. That's not our answer. We have to keep going. They want me to make it a sum of multiple logs. That's just one log right now. So my next step then is going to be to make it a half log base b of 2 plus, whoops, the half's going to go on both of them, a half log base b of x, right? Because it's 2 times x. Multiplication, which is a hard job for one log, becomes easy, becomes adding for 2 logs. Both have the same base. Both have the half in front of them, right? Because the half was in front of the whole thing. So when you break it up, the half's in front of both. And there's the 2, and there's the x. The logs added, right? Because multiplying goes with adding. Multiplying in one log goes with adding for 2 logs. Easy job for 2. All right, last one down here. They're saying write this as a sum of logs. Okay, log base 2. There's the 2, the base. It's lowered down a little bit. So that's going to be log base 2 of x to the 4th plus log base 2 of x minus 4, right? Because this is times here. multiply for 1 log becomes an easy operation. It's just adding for 2 logs. It's easier. Okay. Now what can we do? We can say power down to the front. And that's basically it. There's our answer. We can't do any more. Do you see why the power only went on one guy here, but it was on both guys here? Because that power is only on the x, right? So it only goes in front of the x's log. There wasn't a 4 power on the other guy, so there better not be a 4 in front of the other guy. Whereas here, the half power was on both the 2 and the x, so the half ends up in front of both logs. There's the difference.